Hi team, welcome to this, which is video 3 for forces and acceleration. We'll be drawing upon a kind of knowledge that we've developed so far, but the key thing we're going to be drawing on today is Newton's second law. So Newton's second law, sometimes referred to as N2, says that the resultant force applied to an object is proportional to the acceleration of that object. We say that as F is proportional to A, and that famously the constant of proportionality there is the mass. So force is equals to mass times acceleration. Now, that means that this, which is the resultant force, okay, it's always the resultant force, F is equal to ma, and it means that the resultant force will be parallel to the acceleration. That's because, if you remember, that any vector that's a multiple of another vector, a scalar multiple of another vector, is parallel to it. That means that the force and the acceleration are parallel, and that means that they point in the same direction. If we have an acceleration in one direction, we will have a resultant force pointing in exactly the same direction. So just very quickly, we need to have a sense of how we calculate the weight of an object. Okay. Now, the weight is the force caused by an interaction of the gravitational field of the Earth and the gravitational field of any object with a mass m. Okay, it's the interaction between two gravitational fields. Now, maths, don't need to go into the kind of minutiae of how that force operates, but weight is a force. It is not a property of the object like mass is. Okay, you and I have a certain mass, which is represented in kilograms. Our weight is dependent upon the gravitational field of the planet we're on. Okay, so your weight will change on a different planet. So different on different planets, your weight would be different. So the weight is a fact of the interaction between your mass and the gravitational field of the Earth. Now we know that the acceleration due to gravity on Earth is 9.8 meters per second squared. We should remember that from SUVAT. And we can also therefore calculate the weight of an object with, say, a mass of 20 kilograms by drawing a free body force diagram. If I know that it has a mass of 20 kilograms, and if I assume there's no resistive forces, and that would mean that the acceleration due to this force W is 9.8 meters per second. Now, if the resultant force equals the mass times the acceleration, that means the weight equals the mass times by g. Okay, and this will be true for always calculating the weight of any object with any mass. So W equals mg, and in this particular case, I'm going to do 20, which is the mass, times by 9.8, which is g. Okay, so to calculate the weight of any object, I'm going to times the mass by g, which is the acceleration due to gravity on Earth. Now, we're going to be using that sometimes as we start calculating, but let's have a look at a couple of examples. Okay, so we're going to consider the free body force diagram shown, and we want to calculate the missing forces x and y. Okay. Now, the first thing when we look at this free body force diagram is to notice that we've got an acceleration pointing downwards, which according to Newton's second law means that my resultant force will point downwards as well. So I'm going to resolve to begin with downwards. Okay, so if I resolve downwards, I'm going to have the weight, which is 15g, plus 5 newtons. Okay, now sometimes they'll place an arrow on the top here just to try and confuse you, and that's subtracted from that is x, the force x newtons. Now, this will give me the resultant force. I'm adding together the vectors, so 15g plus 5 take away x. Now, I know, because I have a resultant force in this direction that's given by the acceleration, that that resultant force will equal the mass times the acceleration. So I'm going to have 15g plus 5 minus x equals 15 times by 3. And now I can start to rearrange this. I'm going to have 15g plus 5 minus 45 is equal to x. And then that's an equation I can solve. Which will give us that x is equal to 107 newtons. Okay? 107 newtons. Now the difference here is that because I have an acceleration, I no longer have balanced forces as I did on the previous sheet. So that's allowed me to find x. Now to find the value of y, I need to have a look at my horizontal forces. I'm going to resolve horizontally. and I'm going to do that y newtons minus 16 newtons is still equal to the mass, which is 15, multiplied by the acceleration. Now in this case, again, I have to be really careful because my acceleration horizontally is not going to be 3 meters per second squared. My acceleration horizontally is just going to be 0. Okay, so 15 times by 0 is 0. That means that I have balanced forces horizontally, and so my value of y is 16 newtons. And so that allows me to find the value of y. Let's have a look at one more example. And this one, I'm going to have to draw my diagram from the description. So I'll give you a second just to read the question. I've got a mass of 6 kilograms, so I'll draw my mass of 6 kilograms. It's pulled along a rough horizontal table by a rope with a tension of T newtons. The frictional force exerted by the table on the mass is 13 newtons. Now, I will also have a weight of 6g and a resultant force I can label as, a reaction force I can label as R. Now, part A tells me that given the box starts at rest and after 5 seconds is moving at a constant velocity of 12 meters per second, calculate the acceleration of the box. Now, occasionally questions will do this where they'll start asking you about acceleration or calculating acceleration, and this looks like a SUVAC question. Okay, I've got a time, I've got initial velocity, given that it starts at rest, and I've got a final velocity. And the reason it looks like a SUVAC question is because it is a SUVAC question. Okay, I'm not always going to be using forces. Questions with forces and acceleration and SUVAC will interchange and mix and match, so we do need to be using all of our mechanics skills to solve them. So because it's going to be a SUVAC question, I'm going to structure my 5 variables. Now S, I do not know. U, I'm told, is 0 meters per second. I'm told it starts at rest. V is 12 meters per second. A is the thing I'm trying to find. And T is 5 seconds. So I have V, U, A, and T. So I need to use V equals U plus AT. 12 is 0 plus A times by 5. And so A is 12 divided by 5, which gives me 2.4 meters per second squared. Now, it then says, hence calculate the tension in the string. At this point, I'm asked to calculate one of my forces. Now, tension is operating horizontally, so I'm going to resolve my forces horizontally, and I'm going to have T minus 13 is equal to mass, which is 6, multiplied by the acceleration, which I've just worked out is 2.4 meters per second squared. So 6 times by 2.4, which is my acceleration, and I have a situation where T is equal to 13 plus 6 lots of 2.4, which gives me the final answer of tension as 27.4 newtons. Now those are the kind of 2 examples for this sheet. That should be enough to get you started. If you need any help or you have any questions, please do let me know.